generative AI talk. This is a 101. Oh, I lied.
Oh,
I lied. We were not recording. Because I told them, don't say anything you don't want to be recorded.
oh my, oh my. Now, so you've missed your chance.
Yeah, there you go. Okay, so a little bit about myself. So that's a photograph. I've used generative AI to render the photograph using like a Monet style. So generative AI right there, ladies and gentlemen. 30 plus years of experience. So I have a fellow IBMer back there who worked on the issue, so did I.
Oh my.
Don't blame me.
Yeah,
Yes.
there you go. Me neither. Studied neural networks in the early 90s. That's where I took my first neural networks class and I got hooked. I played with it, but there wasn't that much you could do at the time. So I didn't really start delving into it until a little later. Spent the last decade using AI, and I'll go into a little more. Worked for Microsoft Research. It was a project based on deep learning. Have you heard the term deep learning? Do you know what the difference between deep learning and other learning? We will cover that today. And then I am right now, I work as a developer advocate for a company called StarTree, which is a startup.
I totally read Star Trek when I first saw that.
Oh, yeah. That's how futuristic she is.
Yeah.
It's amazing.
It's awesome. All right, so we'll talk about a little bit of history. So, AI has been around for a while, and depending on your way of classification, and we'll talk about classification later, but depending on your classification, you can say that it started even before the 40s. But officially, what was going on back in that time was ARPANET was a thing, and DARPA was funding it, and they were trying to do AI, and people were convinced that general AI was going to happen in 20 years. This is in the 40s. So, a lot of stuff happened. In 1956, Dartmouth actually started AI research formally for the first time. And, they were spending the government's money freely, doing all kinds of stuff. And they had some amazing projects. So they had language recognition at the time. They had simple logic, kind of expert system, algebraic, linear algebra solutions, and that kind of stuff. All that happened. But then in the 70s, we call it the first AI winter, but I'm just going to call that one AI winter because the DoD stopped all funding, and then everybody just scattered and did other things. So the next thing that happened was in the 80s, you had this thing called expert systems. Has anybody heard of expert systems? Yeah, so expert systems is more of it's not if else. So yeah, it's not a whole bunch of if else, but it is branch logic with built-in, recognizers and checkers and boundary recognizers and things like that. So it was logic-based stuff, and they were training AI to learn from it. And again, Berkeley sockets had neural networks already working. They were doing some things such as image recognition, but there were like 20 students on the research project, all looked the same. So it didn't really work that well.
No. I thought I only recognized those 20 students.
Yeah.
Didn't even do that.
But the data sets were small, and so it wasn't a huge success. But they were making huge progress back then. But then we had,
all white males, right?
Yeah.
but 20 of them. That's
Right.
not like white or not. That's not a good
Right, it's
data
not a
set.
data
Yeah.
set. Yeah.
So data wasn't there. So then we had interwebs. Interwebs happened in the 90s,
Nice.
and things started heating up again. Anybody remember when Deep Blue defeated the chess game for the first time? And this was IBM. And of course, then we have big data, and then anybody watch the documentary on AlphaGo? Do you know what AlphaGo is? So Go is a super complicated game, much more complicated than chess, but AlphaGo Zero is the cool thing because AlphaGo Zero learned by itself, not got taught. AlphaGo was the first iteration, but AlphaGo Zero is great. If you can, go check it out. Okay, so that's history. I don't have, I'm not gonna go over the history because it's a long story. There is a book on the history of computing, and I forget the name, of course. I will share it at the end of the session. Amazing book, all the way from the 20s to modern day, and all the but anyway, another thing that's very confusing, people talk about AI, they're talking about ANI, which is artificial narrow intelligence, which is what all of us do for a living, right? And people talk about AGI as if that's going to happen tomorrow. It's vaporware, I'm sorry to say. Ray Kurzweil, do you know who he is? He's a Google scientist, amazing guy. He's convinced that it's about 5 to 10 years away. Is that the right prediction? We're not there yet. We don't have AGI. Whoever that scientist from Google who claims there's conscious chatbots.
Right.
Yeah, I don't know.
Do you think, we really think it's that far away? 5 to 7?
That's Ray Kurzweil's opinion.
Well, how are
I am
you
not
seeing-
going to confirm or deny.
No, nice.
Look, for somebody who worked in AI day after day and had to train and retrain and overcome bugs and stupidity and retrain for another 10 million iterations, it's not happening tomorrow. Right? Unless there's some lab somewhere, somebody's doing some crazy stuff. I don't know.
I heard the model from Google and the ChatGPT is already passed the Turing test, right?
Yeah, it is. It is. And so, in the history slide, that was the first time people realized Turing was the guy who came up with the Turing test. Unfortunate name. He actually predicted that intelligence will be at par or surpass humans. And that's where the whole thing started, right? But the Turing test is easy to fool.
Yeah.
It really is.
You guys
And
haven't
if
realized
you-
yet, but she's actually a robot.
No. Wow.
Yeah.
Westworld.
And it falls
Yes.
into the Chinese box paradox, doesn't it?
Ooh.
Yeah. It's
You don't know if it's Chinese or not? What is the Chinese box?
Imagine there is a robot that
Yes.
can read an entire dictionary
Yes.
of Chinese and a grammar book of Chinese, but doesn't understand Chinese, and you send letters beneath the door. So it's like, although the messages that comes from the actual paper make sense because of the rules established, it doesn't exactly mean that the robot actually understands the language in a semantic way.
So it's just a very efficient if else. It's not, but it is. And I'll go into the specifics of it a little bit.
Love
But it's a rule set, it's an expert system, more like I know people who would not pass the Turing test, and I know chatbots. So
That's so true.
so AGI is vaporware at this point. Not saying it's impossible, but it's not there yet.
It's artificial.
ASI
What's
is
a G?
general
General.
intelligence. ASI, which is what the movies are made of, it's even further away.
Is it super?
Super intelligent.
Oh.
So that's what all the dystopian movies are. We're not there yet. Hopefully,
You
I
never
don't
get
know. I may escape the longevity trap, the death trap before ASI happens, then I might have to deal with it, but it's not there yet. Okay, so what we're going to be talking about is ANI, right? I'm going to talk about ANI today because it's not vaporware, it's really here, and that's what we're going to talk about. So since we mentioned that, some additional terms, AL, ML, DL. So AI is artificial intelligence. There's a definition that if you want to read it, machine learning is a subset of AI, right? AI is a theoretic, it's concept. Machine learning is how you do it. Is a subset of AI which uses statistical methods for learning something. So what's a good example? Does anybody know a good example of ML versus AI?
Regression.
Yeah, regression is a good example.
Neural networks, okay.
Decision trees.
Yeah.
Boosting.
Awesome. You're gonna like my algorithms.
Oh, nice.
And then deep learning is of course a subset of even ML. So anybody know what deep learning is?
I think the answer is no.
Is it when you have stuff study?
Yeah. So it's more complexity, and it's not the same as deep reinforcement learning, and we'll talk about that. But deep learning is a subset of ML which does more layered computations to learn deeper. And again, I'm going over some really like high level terminology, and we'll jump into lower level in the following slides. So
Would deep learning be like how they teach cars to navigate traffic by themselves?
By crashing?
that would be, it could be reinforcement learning, but we'll talk about that. We'll talk about that.
One example that I heard that was very nice of deep learning is Todd was at the door right now. You can only see his head,
Oh,
but you still know that there's a human there, right? Because you see his head and you imagine that his body is still there.
I thought you were saying because deep down, you know he's there.
Yeah,
Yeah,
But
the
no,
computer is not good at that, right?
but
Right.
that's real, and what she mentioned is more reinforcement learning, and we'll talk about that again. But this is why the terms are important, because everybody uses them interchangeably. And so let's talk about data algorithm and model. What's the difference?
Damn.
What?
Sorry.
You like that algorithm and so it was sexy for you? Is that what you said,
No,
Dan?
it's data algorithm and model. Damn.
Damn. Oh, I'm sorry.
So data is raw data, of course. One of the reasons why AI in early years failed was because there wasn't enough data. We have way too much. Depends on perspective, maybe not enough. Algorithms are the ones that kind of make sense of data. So if you're using, anybody use Azure AutoML or AutoML engines anywhere? What they're doing is they're taking algorithms and running your data through all those and say, hey, which one predicts the best? So that's kind of like, you're running your data through. That's what a data scientist would do. They would have cooked algorithms. They would try to find relationships. And then the model is the final thing that they settle on, which is more of a kind of like a function. It's not a function. Don't bust my chops on me. But it's kind of like that.
Well, it can
You've
be.
achieved, yeah, it can be a function.
A model
But-
can be.
But you've achieved the pattern reliably enough to where you know that this is the model that works. Okay, so now, here's a good example that I found. So, this is more terms. So what is an attribute, what is a feature, and what is a parameter? So attribute, features, and parameters. So in that statement, where you're seeing y is equal to 0 if 5x minus 3 is greater than 0, else 1, right? So if you're putting this would be a model. This is a function that we're using to sieve our data through, right? So this could be a classifier function, right? Could say it's either 0 or 1. The results are binary. So if you're sending your data through this function, the attribute is x. Okay. Feature is a set comprising of x less than 3 divided by 5. And the parameters are 3 and 5. And the classifier, the class is the y. So that's your model. Okay. All right, so that's just terminology, just so that we're all speaking the same language. Now let's talk about, there are 3 broad categories of AI, supervised, unsupervised, and reinforcement. So can anybody guess what supervised learning is?
This is what Todd does with the students. I'm sorry. What were you saying?
Like when you have a human person, like curating the information to teach the machine if it is veridic or not.
Yeah, so, yeah, yes and no. The way supervised learning works is that you have this is the technical term, you have a shit ton of data. And then you have to,
STD.
you have to label it in order for something to happen. So what you do is you label 90% of the data, run it through algorithms, and then you take the 10% and you test it, right? So the test data and the training data. So that's supervised learning. It uses STD,
Sure.
and you have to label it. So anybody use reCAPTCHA?
Oh, yeah. Are we training?
We are training.
Oh, no.
We are being the minions. That's what's happening, by the way. And it's true. It used to be CAPTCHA, and then some genius figured out, oh, this is human power. Why not, why not use it? So they call it reCAPTCHA.
Wow.
It's kind of cool. Unsupervised learning is when you don't label the data, right? And I'll go into examples a little more. And then finally, the reinforcement learning is no data. So this is, simulating a car driving and running exhaust. This is how AlphaGo 0 was trained. So there's no data. Okay, so let's take a look at it. Is it a muffin or a dog? This is a classification
Gotcha.
problem. Right? Muffin or dog?
Yes.
It's harder than you think. When we first started using AI to focus on a face, you could fool the camera to focus on your face. You could fool it by like a happy face drawing because the data wasn't trained enough, the model wasn't sophisticated enough, you could fool it. Now we've come to the point where we've trained so much data that it can actually tell the difference between a muffin and a dog, which is always nice. So classification is when you have labeled data that you train. That's one of the problems that supervised learning solves is classification, right? It'll take your STD, shit ton of data. I don't know which one is worse. And it'll.
We call them STIs now.
STI? Shit ton of inputs.
Information.
Oh, smart.
And it'll take that and then it'll we label it. And then we train the model using the label data. And then we feed it unlabeled data and it's able to figure things out. So if I have 1 million pictures of dogs, another 1 million of blueberry muffins, and it learns what the features are to look for. So it has to be a nice little triangle. If the triangle is off, then it's probably not a dog. But then again, there's other features. There's a mouth underneath the nose. If that's missing in the picture. So these are all, think about it. We're just talking and we're figuring this out. The training is millions of iterations. So it's learning more, it's noticing more things that you and I probably ignore, but it's learning all those little things about the data and it'll figure out. So that's classification.
So, but you couldn't query it to have it tell you, oh, I figured out the mouth or not.
Yeah, you can list the features. So once the model is trained, then you can kind of look at how it arrived on that. What are the features that it's looking at? So that, remember the formula that we looked at? It found the features that matter. So feature engineering is another branch of AI, where if you have, again, check on data, and you've labeled every column, and it's got 1,000 columns, and you have, hundreds of millions of rows. You've labeled every column, you're running through algorithms. You may realize that it's only using 3 of the columns to figure out things. All the rest of the stuff is extraneous. So those are not features, like they're not important features. It's only using certain things. So yeah, you can look at the algorithm and the model to figure out what the features are, but when you're training it, it does the work of figuring out which of the feature discovery and all that stuff. Or you can tell it. You have control over that. So the next is, somebody said regression. So regression is another algorithm that is used for labeled data. So, yeah, it's labeled data. So what is the difference between supervised data? So what is the difference between a classifier and a regression? What would you say?
The classification, you just have like 0, 1, it is, it's
Yeah.
not. With regression, it's like regression, so you have numbers.
Yeah, so regression is used for prediction. And so usually what happens is you take the data and you look at, is there a pattern forming? And if there's a pattern forming, you can see that there's a line that describes this pattern. This is a very simplistic regression algorithm. The lines could be kind of curvy or whatever. But the point is that you can kind of see that we have found an algorithm that defines the trend, and the trend can be carried out to future and do prediction. So how many of you have actually used these algorithms? Okay, so what is one of the things that you know about using the algorithm? When you run something through a model, what does it give? It gives you a percentage. It doesn't say, hey, this is for reals, 110%, not possible, it's probability. So it's 98% it's going to be a dog, or 3% chance of muffins, right? Or there's a 98% chance that you need to order more tea because we're running out of tea. So that's the kind of stuff it does. So because what it's doing is it's a probability game. It's using formulas to do look at patterns, and it can only predict to a certain extent, right? So that's predicting. Does this make sense? I mean, yeah. All right, so let's talk about unsupervised learning. So this is great. We can take all our data, all our STD, and train, label everything, and say, hey, classify it as dog or muffin, or predict how much inventory I need to order, whatever, right? That's the great usage, useful information. But how do you protect like a hack or an attack on your network or something like that? Unless you have existing data to train, you can't predict it using supervised learning. So that's where the unsupervised learning comes in, where what it does is it takes, again, your ton of data, it's not labeled though, it's just data. And it figures out patterns in it, right? So it'll take the patterns and it'll say, oh, whoops, that's an anomaly. Your normal range is this, and there's an anomaly. So that's anomaly detection. This is how we use unsupervised learning to figure things out.
And you unsupervised, you're still trying to put the data into classes, but you're letting the computer decide those classes, right?
It's not. It's actually just anomaly, right? So it's the computer doesn't know anything about the anomaly. It just knows this thing is not like the others, right? That's all it
That's still
knows.
a class, right?
It could be good. Well, you can call it a class, but it could be. This is normal, and everything is a class. You're calling abnormal, so fine. That's fine. but it could be different type of anomaly. And there are complicated algorithms that say, hey, if it's here, it's this type of anomaly. If it's here, it's this connected one to classification. And yeah, but. So yeah,
Thank you.
technically, yes.
So it's more like you have a norm and then you have a mean, and then an outlier would be like 2 standard deviation outside.
Mm.
Yeah, so if you look at the algorithms, you'll see, right? K nearest neighbor, local outlier, those are all statistical algorithms that look at means and variance. And we'll talk about that in a minute. So the next one is clustering. And this is also a use case for unsupervised learning, which means unlabeled data. And then you just throw the data around and see where clusters form. And you're like, huh, that's interesting. Why is there more Slurpees sold in Minnesota in winter than any other place in the world? I don't know, but it's real.
I'm from Minnesota, there's nothing else to do.
There's your answer.
It's a cluster. We don't know the why and the how. but
You,
it's a
you got
cluster.
an unsupervised answer right there. Yeah, that's good. That's good example.
It's actually sort of the bowling alleys.
There you
That's
go.
where we are.
Amazing.
There you go. Now I know. See,
Trying
learn
to help.
something all the time.
Well, I think in India, it's blazing hot and they drink hot tea. You know, Minnesota in the winter, is it
Slurpees.
cold? You gotta drink
There you
Slurpees.
go. There you
That
go.
makes sense.
I have no idea why that is, but it is. But yeah, so you'll notice that there is commonality between the two use cases for supervised learning and the 2 use cases for unsupervised learning. Basically, if it's a spike, it's called anomaly. If it's a cluster, it's called clustering. It's the same kind of thing. What you're doing is you're looking for patterns, right? And in the other one, if it's binary or if it's well-defined classes, then you can say, and it doesn't have to be binary. It could be muffin dog or polka dots. I don't know, something else. It could be multiple classes, but the idea is to kind of put things in one category or the other.
So anomaly and cluster is pretty much the same, but it doesn't happen in more than one access. It has more than one dimension.
Yeah, so the idea is that, the kind of data and the kind of tuning you do for anomaly detection is slightly different than clustering, and the reason is different. So you pick different features. So it's using the same types of algorithms, right? But the use is very different. Use case is very different. And you're absolutely right. So the clustering would be clusters, whereas the anomaly detection would be blips. or
One
whatever.
waveform.
Yeah. All right, so now, so this is what I did for several years at Microsoft Research, which is reinforcement learning. Reinforcement learning, anybody watch 2-minute papers?
Mm-mm.
Dear scholars.
Should we? Well, I guess clearly we should have.
Definitely follow him on YouTube. What he does is he takes all these deep reinforcement learning algorithm papers and makes them into cute, explainable videos, and it's amazing. And his accent.
2-minute papers.
2-minute papers.
Mm.
It's
What
amazing.
is his name again?
I don't know
2-minute
the-
papers
The,
on YouTube.
the channel is called 2-minute papers.
I literally typed 2 into YouTube and 2-minute papers AI was the first thing.
Amazing.
Yep. So anyway, the way this is done is, and if you hear the word industrial metaverse or things like that, you're talking reinforcement learning. And so the way this works is that there's no data. This is the way children learn, right? Children walk around, they see everything, they want to touch it, and they want to eat it. And basically they're collecting data, right? They're interacting with their environment and they're immediately rewarded. They touch something that's soft, nice, or they touch something that's hot, boom, they learn something from that. They put it in their mouth, it tastes like STD.
Yeah,
Or it tastes sweet,
right.
and then they just bite on it. So reinforcement learning. If you watch the documentary, and I don't know the name of it, the documentary of AlphaGo Zero, and I do recommend you watch it. The thing that was really cool was the computer played against the world champion of Go. And this guy, his deal was that he was cool. He never got startled. He never made a mistake. He was awesome. Like he was so confident and he kept his cool. And the machine made moves that were so idiotic looking to him that he got rattled. He was confused and he got beat. And he actually contributes to the team now. So he's working with them. But that's the point. And if you watch the 2-minute papers, sometimes you'll see reinforcement learning is weird because, one of the examples there is they have a biped humanoid and they were teaching the biped humanoid to climb on obstacles to go from point A to point B. And you and I, we've walked so much that we would kind of think and plan our way and we go around or climb up. Well, these guys were going backwards and flipping over because they're AI. They don't have any data. They don't have any patterns to follow. So they were doing all this bizarre stuff that, so that's a challenge of reinforcement learning. It takes longer, but given enough time, it'll cover all paths.
I think something important to mention about Go is that it doesn't have any rules, right?
Go doesn't have rules. Yeah.
But I heard that there's nakeds, so you have some set of rules.
You have, well, yeah, I mean,
It's
you
not
have
like
to have
chess, which is
rules.
fixed rules. It's very
Yeah,
open rules.
chess is 64 moves, Go is infinitely more, and then there is a rule of objectives, but how you arrive at it is much more complicated. So it has rules, but it's not as
It's not
obvious as chess. So it does have rules. So it learns by playing. But the thing is, a Go player could have played, maybe 100,000 times in their lives. The agent plays it for like multiple millions, maybe even 1 billion times to learn. So they have the advantage. I have friends who are like, oh, I would never let a robotic doctor operate on me. I would. They're never going to be tired. They've never had an argument with their wife or husband or son or daughter, and never got cut off on the way to work. And so that's the one thing. And then the second thing is about cars, self-driving car problem. Anything that one car learns shares it with all the others. So it's not an individual that has to go through the entire learning process. They share that, the data. Did you have something to say?
No, he was struck when you mentioned cars, he was like, PTSD.
No?
Yeah.
You just go right over them?
No, I don't.
Never work in Hill.
Yeah, when interesting thing about reinforcement learning, it's being used in conjunction with other models now, right?
Yeah.
To
Yeah.
fine tune a little bit.
So I'll give you an example of one of the projects that the Microsoft research team worked on. And so they're using reinforcement learning to solve industrial problems. So here's an example. So who likes Cheetos?
Well, I think everybody says, yeah.
Right.
Who does it?
So here's the process of Cheetos, right? Cheetos is pretty much cornmeal, water, and then flavoring. You mix it up, and then you extrude it, and you'll be surprised how many things in our day-to-day life are extruded.
Oh my.
Extruders are everywhere. You extrude it, and then you send it through an oven, and it bakes, and then you got Cheetos. Yeah.
It took
The
1 billion
problem
times
is-
to try that formula to get the
The
right.
problem is the extruders are like $1 million machine. So it's not easy to start up a Cheeto factory. You need a little bit of funding. And then the other problem is every Cheeto factory in the world, which we have everywhere around the world, there's a foreman who comes every 15 minutes to every assembly line, eyeballs the Cheetos, and figures out whether it's the right moisture or not.
Wow.
And so then they walk away to the next one, and then the next one, and the next one. And to become a good Cheeto inspector takes 10 years. The newbies don't do that good of a job. It takes them a while. And not to mention, people are not signing up to be Cheeto inspectors.
I didn't know that was a job opportunity.
Who wants a factory job anymore, right?
Right.
Everybody wants to be a barista.
I'll do it.
But anyway, so the team that I worked with at Microsoft Research went and worked with PepsiCo Research. And they went and they interviewed the experts. And each expert had a different way of figuring out how the Cheeto is the right texture. And the variability is not in the amount of flour or the cornmeal or the water. It's not. It's on the crop. Because some cornmeal is wetter than others. It has more moisture. Some years are drier. So it's not a simple matter of, hey, just fix your weighing scale. No, that's not the problem. So they actually put cameras, and of course, computer vision notices a lot more stuff than the human vision does. So they were able to look at all the nooks and crannies of the dough, the extruded Cheeto, to immediately say, this is a little wet or this is a little dry. And so you extrude the Cheeto and then you send it to the baker and then it turns. If it doesn't turn, if it's not that curvy little thing, then you're not going to be happy with it. Cheeto fans know the curve. And the crust.
It's a smile.
That's right.
There you go. So, but that's the point is, that's a batch wasted, and they implemented this, and now they don't need to train the people. So two things happen. One, they can use the automation. So they created a simulator, by the way, simulated the conditions of Cheeto, and they were, yeah. And then they were able to train the model to make the perfect Cheeto. And so now it can be deployed everywhere. We're talking about self-driving cars, which is a complex problem. Why is it a complex problem? Because what people don't realize is how much part of our brain is taken up by eyes. And some people even say that the eyes are not an organ, they're part of the brain. They're just specialized brain.
Wow.
And they're taking in so much input and processing it that it's very complicated, and we haven't quite gotten to the point where solving that. But trains can be automated. They run on tracks and they have less obstacles. They don't have, as many challenges. They don't have people cutting them off. I've seen cars versus trains. But talk about.
Just saying, Dade County, I mean, come on.
So tugboats are, if you're a shipyard and you are operating tugboats, there may be one ship that needs to be brought in every 8-hour shift, but you have to hire the tugboat and give them all the benefits. Then you have to make an automation tugboat, and basically it's bringing ships into docking. So it's a known, it's not as complex as something like that. We have drones that are autonomous that inspect towers. And their path is not as complicated. GPS is not always available. So they're doing it by sight and wind. And so, anyway.
Wow.
Let me not get carried away. So, okay, so some algorithms, I'm not going to go into a lot of this. So this is decision tree hierarchy. This is simple. Everybody kind of should have an idea. This is your if else kind of thing. It's a little more complicated than that, but it is. Random forest is a group of trees for more varied data points. So you have multiple decision trees, and then you come to that. Support vector machine based on statistical learning frameworks, scatter plots. So this is more of a the regression problem. So you draw the scatter plot, you look at, hey, is there a pattern? right? And that's how you, naive Bayes, everybody should know statistics.
Oh my,
It's not as naive as they think.
naive
What did you say? Everyone should know what?
Naive
statistics,
Bayes classification.
or is it everybody naive? That's what
It's
you
not
just
as
said.
naive as you think it is.
I literally teach 5 of these in our
Right,
data
right.
analytics class.
Yeah,
Nice.
yeah. Linear regression, nearest neighbor. Again, the terms should tell you what it's doing. Nearest neighbor for clustering and anomaly detection, right? Local outlier factor, similar to Canon, different algorithm. So more of these. Boosting and bagging.
Oh,
There's a young lady who brought in boosting. So boosting is a common technique used in AI. Basically what happens is when you were talking about features, right? Not all features are created equal. So if the classifier for the dog versus muffin, the triangle is not perfect, that has more weight than some other subtleties. So that would be weighted, that's boosting. Bagging is what you want to do is you want to duplicate data or create additional data to improve algorithm. So anyway, I'm not going to go into all these. I will share the link to this presentation with you, so you don't have to memorize anything. Generative AI is my favorite thing. So that is a picture that a generative AI painted of what I should look like.
oh my.
I think you look better.
Yeah.
We're not there yet, people. One prompt. No refinement. So, but anyway, I kind of did my best to describe myself and it came up with that image.
Oh my.
So that's generative AI. So it's an ensemble
So
technique.
that's your interpretation of yourself.
Could be,
Ooh.
yeah.
Of what you
Very
should look like.
clever. Yeah, make it all about you.
Impressive.
Spoken like a teacher.
Indeed.
What are you doing wrong? But it's an ensemble mechanism. What it's doing is it has the interwebs data, learning from it, and then it's using deep reinforcement learning techniques to fill in the gaps between what is and what's not. So that's one of the ways that generative AI works. It has all this data, ST, and it's learned a lot from it, and it does a prediction based on it. So it's mostly data-based, but it has some deep learning techniques that it uses. One of the things that one of my colleagues wants to do is an LLM lab, David.
Yep.
So before we do the LLM lab, I wanted to do this because let's at least get on the same page, right? And then LLM,
Oh,
our favorite LLM. So this is large language models. It's a subset of generative AI. Generative AI can be audio, video. Have you guys seen audio sample that, people making songs and the sound of this and that? And so generative AI can be visual. Yeah.
smart ass. That's good. That's good.
It's a very good.
He was paying attention.
classifier. It's a classifier.
He understood the assignment.
There you
He's
go.
way too smart. You didn't trick him.
That's right.
Yeah,
Maybe he's not really, he is an AI.
So generative AI is all the buckets. LLM is just the language part of it, language model. Pre-trained with large amount of language data, uses natural language processing, which has existed for a long time, and combines some deep learning with the data techniques. So that's my presentation.
Impressive.
I will take questions, but in the meantime, the QR code is for my company's website. So
Nice.
if you do scan and go there, I get brownie points. It has nothing to do with AI, but I'd like you to scan it anyway. The bottom link is from the organization that I run. It's the South Florida Women in Technology organization. Please, if you're a woman, please join. And the others, some of the places where I found some of the materials that I listed for this slide. So reference materials. Wikipedia is a good place, believe it or not.
Nice.
They don't lie about AI, or maybe they do. I don't know.
We will, that's what we have, that's our homework then.
But they don't lie about algorithms and mathematics and statistics. Let's just put it that way.
So recently, Elon Musk said that we should all work on AI. What's your thoughts on that?
Until his catches up, that was it. The bottom, that's what it said. Yeah, until his version catches up.
Elon Musk, but I want to hear her response.
Yeah, listen, if you don't do it, somebody else will do it. Sam Altman started as a OpenAI project.
I think
He got paid millions of dollars.
Corrupted.
That went nowhere.
Yeah.
But Elon Musk contributed to OpenAI, right? So again, I'm going to say that we're not at AGI yet. We are at ANI. Everything that we're doing is narrow implementations. Who knows what's going to happen with quantum computing? When quantum computing shows up, then AI plus quantum computing means faster learning. And then what threshold that breaks is anybody's guess. So what is happening is, and I'm gonna sound really old, but there have been people who said, oh, well, television will rot everybody's brains and internet will kill this and that. I will give you that it's not the same. It's a different level every time. It's like we're going around in circles, but we're not on the same circle. If you look at it 3D, it's a spiral. It's not a flat circle. We're not in the same place. So it's a complicated world. I don't know. I'm going to be part of it, not outside of it. So the answer is I don't know.
So in the circle, you won't be the anomaly, huh? Did I get that? I learned something?
she's just, further up the spiral than we are, that's all.
All right.
Yeah, but it's inevitable. If Elon Musk stops it in the United States, India will do it, Korea will do it, China will do it, so it is what it is.
So
should
I'm
we be
hearing
cautious?
whiny baby, is that what you're saying?
I look at it more as a Prometheus thing,
Yeah.
Oh,
is fire good or bad?
To be fair, Elon Musk funded OpenAI.
Yeah.
For the 9 reasons, and they were never gonna go commercial.
Yeah.
I have a question. I went to the OpenAI, the global camp, and we were using a model for form reading,
Yeah.
you remember that? So are there any other resources that we as regular people can access that can?
Yeah, so depending on who you're accessing it from, so that was a Azure sponsored thing. There's something called cognitive services. So cognitive services is human services, reading, voice, that kind of stuff, facial recognition. There are pre-trained models everywhere for it. GCP has it, AWS has it, Azure has it. You can go play with that. What you're doing is they've already trained the models, and all you're doing is you're using it. You can add some more parameters around it to say, hey, I'm taking a facial recognition cognitive model, but now I want to filter the results by only Hispanic women or something like that, right? I don't know what your criteria is. So you can enhance it, but these are pre-trained models that you can add on. You don't have to collect all the data. And that's what we're doing with ChatGPT. They're pre-trained models, and we're just kind of giving it more like parameters saying, hey, operate within this context. So when you go and do the prompt engineering, saying, imagine you are a Kafka engineer and you are streaming, write me code to do. That's setting up the context as parameters because ChatGPT 4 is trained on all the internet. And when you say Kafka, it might want to go find something. When you say STD, it might look up
Something else?
something else.
Yeah.
It has no context.
Stuff to do, exactly.
Yeah.
That's very good.
I just wanted to make a really quick pitch, if that's okay. That starting on Monday night, we
Oh
have
my.
a class starting here. That's 3 weeks, 3 evenings a week, on AI and machine learning, data analytics and Python. So it's, you know, it's a little bit deeper of a dive into like the specific algorithms and how to actually do the data analytics and apply them if anybody's interested in taking it further.
Right.
Nice.
But it is a pitch because it is a paid class and
No,
this
it's
was
great.
this was totally free and awesome and amazing and
Yeah.
I'm may not be as knowledgeable as Barkha is, but
Yeah.
you know, if you
But this is the problem, is that people will sign up and then they'll learn about like, oh, I'm using this algorithm and I'm memorizing these 5 algorithm names and I'm learning how to use it without kind of saying, well, why am I using this versus that? Or, you know, what's
and
the.
we teach on Chris PM and the whole process and the why behind everything.
You had 7:30. You want to do
Yeah.
this? So, ladies and gentlemen, just give us a pause 1 second. You want to do it here? Or? Yep. If you can disconnect. No. Yeah. So give us a couple of seconds. Barkha has to just set up something. She of course runs a bunch of different events. She's going to help us. She's going to run one of her events right now. So just bear with us.
Somebody else is hosting it, but I have to start the meeting.
Right.
That's the big thing.
That's where AI can help you. That's where AI can push the buttons.
Yeah.
I'm the head of QA of my job. I think that's called automation. It's not called AI, different A.
Right.
So it's just automation.
Barkha, what other you run?
Give her a couple of
South
seconds.
Florida
Once
Women-
you have to ask the kind of the question out.
Jamie, so she runs South Florida Women in Tech. What other organizations is she running?
Oh, that's a great question. That's definitely a question for her. Give her a couple of seconds. Who's using AI currently in their job? Okay, so what's the examples of some of the things they're using in AI?
What am I using it for? Oh, geez. Well, I've been using a couple of different plugins in VS Code to help automate the writing of some of my code.
Nice.
So that's one example.
What's your example?
I use an amazing flashcard app
Oh,
called Mochi.
oh my.
And if I don't feel like typing the definition of whatever I'm trying to understand,
Right.
I can just put in a tag, an AI tag, and it will go out to
Figure it out.
AI, generate a response, allow me to edit it.
Oh my.
Save it right there. It's really cool tool.
And you sure it's not, what's it's called, you know, it's another infant, you know, AI and then somewhere else doing the work for you.
It might be.
Recapture.
Yeah, I guess a different I word, by the way, the other real thing is a different I word.
It's a small child in India.
That's the word, no, we have a people plug.
I thought you were gonna say another idiot.
Well, that's even better, that's even better.
I don't want to do it. Ask some other idiot.
So I heard one more person here, right in front of us, where we're using that. Yeah.
All right, I'm good. So
You good?
you wanna, yeah, you guys wanna ask questions?
Go ahead and ask that question you want.
So yeah,
Just
Barkha,
give us.
what other organizations are you running? Or
So
part of?
I run a couple of meetups locally. I run the South Florida Women in Technology. I'm on the board of the Data and Analytics Club that also does a lot of the events. The Global AI Bootcamp was hosted by that organization. I have a Microsoft, and again, I'm doing this with other people. I have a Microsoft cloud users group that we run locally as well. So those are the 3, and then I help out with others. So.
And so for women, like especially ones that are graduating from Boca Code that maybe want to get into South Florida Women in Tech, what's the best way for them?
Just go to that URL that I shared and click on.
Perfect.
Awesome.
Quick question about, maybe it's a bit more history, but you mentioned that around between the 40s was the artificial intelligence, like how they achieved to do that, because computing
So
then.
first, the first application, as you can imagine, is, cracking the code for that, whatever the German machine was. So this is just computation by hand and then feeding the computer. And then they envisioned a time where it's not going to be that archaic. So then the ideas behind AI was being developed in those days. So they were more of when the machines get so smart that, we're over the limitation. And there were a lot of physical hurdles at the time, as far as and so they actually believed that they would, in 20 years, they'll solve this, right? It's almost 20 years away.
It always will be.
I don't know about that.
Not anymore.
But they actually believed that that you could come up with logic such that it could solve most problems. And their focus was completely on algebra, linear algebra, and statistics, and they were just using that. What we do now, and so this is just like inside information for the deep reinforcement learning. How does a computer know? How does the AI model know how to solve for whatever? Is it key value pairs that's stored inside or what? How do you know? It's a graph. So most of the models will create graphs because they've learned. So you saw some of the algorithms and models. So some is functions, right? Some is functions. So we use the functions for putting the data through and seeing whether it's a pattern or not, and then it can come up with. But as far as the reinforcement learning, so the one thing I forgot to say, and this is great, right? Okay, so we'll do a reinforcement learning exercise.
Yes.
Okay, so let's do.
Erasers over here.
That's okay. So we got.
It's reinforcement learning, so you get a cookie if you get it right.
Nice.
We got a reward. I don't know what the reward is. So these are some mountains. Let's say that you have to create a simulation to figure out what the highest peak is. How would you do it? So if you remember how reinforcement learning works is that you have the environment, you have an agent. So the agent takes action. And based on the result of the action, it gets rewards, right? And then the environment changes because of the action. Okay, so it's a state change. So let's think of something.
So I will provide a reaction height of the one time that we know the height.
You know, it's an environment. You're a baby. You're walking around, taking things, putting it in your mouth.
You haven't walked the mountains.
Yeah, you don't know. You don't know.
You walk the mountains and probably the time that it takes to get up there.
Okay, so you climb up.
Measure your time.
Okay, and then you come down. And then go to the next one. Yeah. So that's a way. So good thinking. But the way
Can we see
deep
visually?
reinforcement learning works in a chess game, right? Think of a chess game. You don't play the whole game and then you decide whether it was good or not. You make a move and then decide whether that was a good move or not. Then you make another move, then you decide whether that was a good move or not.
That's not true in chess.
It is.
That's
But
reinforcement
that's how
learning.
reinforcement learning works.
Absolutely.
So go ahead.
So what if the model would send light and it would detect where there was light was blocked and where it wasn't blocked and then set up a pattern based on that? Would that be the model?
But it's a good thought.
Oh.
Go ahead. Yeah, so if you have a robot with an altimeter, it takes a step. And then it says, hey, if it's more than where I was, then I get awarded, I get a point. If it's less than where I was, I'm going the wrong way, let me change directions. So yeah, you guys are thinking systemic, I'm thinking step by step by step, right?
You do that.
Take a picture.
Yeah.
Of the mountains, use a ruler. Take like a threshold in the sky.
Okay, so let's say that so again, you're thinking of solving the big picture. Come up with something that will work no matter which mountain. So what about the trees?
Giving me a height measure, you can use how many trees you think this mountain is.
Is the mountain in Morocco or is it in Nepal? The trees would be different. Yeah, but that's my point is that they want to find, yeah.
So considering your way of going, take a step and go up, you're going the right direction. It seems like you're gonna get stuck at the first, you're gonna get stuck at the first peak you get to.
Yeah.
And so I've read that the reason why sex is essential is so that we don't get stuck at relative peaks that are not optimal.
Right, so that's a great point. So if we did use the method that I said, you give the agent an altimeter and you reward it every step that, hey, you're on the right path or not, it's the right way. But then if there's a little jagged peak, right, it's like this, then it's going up here and then it starts going down and it's like, oh, going the wrong way. So turn back. And now it's at a maximum, local maximum.
So what
Now
about
it's
giving
stopped.
it, what about giving it a reward when it reaches a point where it can't see land that's higher than it?
If it only has an altimeter and no vision of the rest of the world.
You give it a reward at one mountain, plus an animal.
Yeah, that's exactly what we're doing. So it takes a step. If it's up, we reward it. If it's down, we either take away a reward or don't reward it. So it keeps doing it. We can create some rules that says, hey, try 10 false steps before we penalize you, right? That's an example. So if it's on a little blip,
So maybe
it's not
reward it,
getting.
maybe reward it more for covering distance than for gaining altitude. So that it's getting a reward for gaining altitude, but it's getting a larger reward for covering distance. So that promotes it to move forward even when it has to go down.
Right. So how many of you have kids?
How many of us what?
Have kids?
Oh, I thought you said 4 kids, yeah.
And if you
I
have
was a
kids,
kid
you know
and I
how
have
this agent is going to learn to cheat the system.
You beat them.
It'll
That's
go
good.
up and it'll go down and then it'll go up again, down, no penalty or half a penalty for down. So it keeps winning, right? For your example, distance and then a little bit of altitude.
Right.
Lots of reward, right? So how do you, so these are some of the problems that we run into. The thing that works is that, okay, as you go higher, the higher the, it's kind of like playing a video
getting
game.
higher
The higher
points.
the level, the more the reward.
Yeah.
So now it's not doing one of these, going up and down, up and down, up and down, and collecting rewards, because the goal of the agent is, I need more points, right? And so if you're a kid who
So
gets
it's gotta
a
find the
chocolate every
highest
time you
peak.
poop, that child will poop 10 times before he's done. And have 10
Right.
chocolates.
It's gonna have really small boobs.
But then what you do is, so the local maximum problem is solved by swarms. So what you want to do is you randomly put, lots of agents everywhere, you swarm the landscape, and then you figure out which is the swarm maximum. So these are some of the types of things, and then again, there's always a way that the agent will try to trick you to learn some off the wall. So these are some of the types of problems that reinforcement learning solves. Interesting, right? So yeah, so designing a reward function is very important. And then designing, hey, you know, how long does it take? Can we make it so that, hey, if I already know that the highest point is, so let's say that this is.
I do have kids and I gotta say, rewarding them for getting high, not a good idea. Oh wait, this is Pete's.
If you already know that this area is flat, then you can write some rules to say avoid this. If you already know something about the landscape, and how do you know about the landscape? By running the agents there. So if the agent's going and not getting anywhere, deactivate that agent. Keep the agents that are gaining up. You decide when that's good or bad. That's all. That's how deep reinforcement learning works. It's not data. It's not using any data. You don't have a picture. You don't have planet Earth. You don't have to have storage. Unfortunately.
As you're working with this, do you look for inspiration in nature and our biological environment?
Yeah. So, you know, that sounds fantastic. And yes, people do, but you're thinking that my job is that glamorous. It's not. But no, but it's true, you know, these kinds of problems, you do have to, so I'm not a mechanical engineer, I'm not a chemical engineer, and most of the problems we were solving in the research lab at Microsoft was either chemical engineering or mechanical engineering problems. So I'll give you an example, right? We want to know that a smelting machine, that's this massive, huge thing that's spinning really fast and breaking overs in the right size for it to smelt. Because if it's too big, it takes too much energy, and if it's too small, it might fall through cracks or whatever. So it has to be the right size. How do you measure that? You can't go into this. If you put the sensor in there, how do you do that? You look to nature. You listen to sound. Sound is a better indicator of that than temperature in that case. So you do. So in that sense, yes. I'll give you another example. So we have a continuous storing reactor, which is a very common problem in chemistry. So all of these chemicals that we use on a daily basis, a lot of them are in continuous storing reactor. And you have to keep adding and moving stuff to it. And you need sensors to figure out if it's the right thing or not. And some of them are corrosive, so you can't put sensor in. What do you do that? You know, you collect the fumes, and you look at the thermal output, and you do other sensors. So these are the kind of problems that we solve with ERL. Again, that agent is never going to escape and take over the world or whatever other fantasies people might have. It's
Terminator.
Right? That autonomous driving thing, it's just going to be looking for things. Am I going to crash? Am I going to crash? It's not. You know, we're not there yet.
Well, Bishop, there's some concept of story of deep learning, I think, or you remember, I'm not sure, like how much can it learn? Right? What kind of score or system is it, and what?
Yeah. So the scoring stuff is in labeled supervised learning. So supervised learning, because it's statistics. It really is statistics, right? It's just statistics done at massive scales and very tough. So that in that case, what you're doing is it's a 98% of it.
I heard something about like deep learning system, and so a very part of these that it's years or a secret. That it could be against China.
Yeah.
That's what we're getting news from 4chan. And trust it.
Yeah, no, I don't know. I'm sure there is, and I work for the federal sector of Azure also. so.
Sure, she can't confirm or deny that.
No, all I can say is there's.
Oh, my.
But there's a difference between research projects and, research and the day-to-day operations, right? So, who knows?
I worked in I work in AWS, but we have a public sector team. They are very far behind.
Oh, my.
On the commercial side, so.
Well, now with ChatGPT, what things do you see like besides helping us to code or to answer questions or everyday things? What other things do you foresee that we can advance?
Yeah, so I mean, ChatGPT is trained on the internet. So anything you can do on the internet, you can do better with ChatGPT.
By the way, if you have any doubts that the US military has some kind of crazy technology that we don't know about, think about how you see them using walkie-talkies in the military, still pressing a button. And that technology was developed 100 years ago, and that's what they're still using today.
Well, but that's, we need something reliable. I have a different up there. I'm XR. You don't want to do that.
Yeah.
I want something.
Here's a trivia. based
Okay,
on
let me put it
history.
this way. If you're a medic and you have to take your hands off of your patient and deglove to use a radio, that's full technology.
Yeah, but the internet was.
Let's see what Barkha says.
The government. And do you know where the origin of the mouse is? Anybody know?
Xerox.
That was before, sir.
Where did they get the idea of the mouse?
Xerox.
No, where did they get the idea?
Xerox was a company that got the idea from somewhere. What was the somewhere?
I don't know.
It's actually a tag for missile drops. You know how they tag guidance system? Yeah. That's where the mouse came from.
Wow.
That's the original mouse.
Have you guys heard about the ninja missile that killed tourists?
Yeah.
It went through a window and just chopped the flying up.
Put on chink.
That's amazing.
Is that a joke?
So-
Hey.
So to your point, it's not that, yes, there's a lot of inconsistencies, but they also fund a lot of projects that are.
Yeah,
So
well,
who knows what they're doing?
the Hubble telescope, when it was built, it was funded by the military. You have two of them. One of them's pointing out, the other one's pointing down.
No.
I cannot confirm or deny that.
You're nice.
I can confirm.
This is a specific question. Can ChatGPT, can you ask it to write a script that actually will scrape data off of the website?
It doesn't need to. It already did.
Yeah.
That's, no. That's what it did. That's,
Trained on all the data from the website, but yeah, you can do that.
They have
I
a
mean,
browser.
one of the biggest things, and who's using GitHub Copilot? That's just code.
What?
GitHub Copilot.
So that's just learned on, it's AI that was trained on code. ChatGPT is trained on the internet. So yeah, sure. You'll have to be a little more, it'll take multiple prompts saying, hey, write a scraper in Python or Node or whatever.
That
You have to
scrapes this
define it a
data
little
from this website in this
but,
format.
yeah.
Right.
Thing, I had a young plumber write some code for me that did that, and then he didn't turn over the script to me. So I want to find out if I can recreate that script.
Yeah.
by hiring another young coder.
Yeah,
Yeah,
That's how you create it.
yeah. I mean, so the thing is, I have an uncle who got a electrical engineering degree in India.
Mhm.
He has a PhD now, but he came here to do a master's degree. And in the master's degree, he was brilliant. He was able to answer all the questions. And he was taught to write code on a whiteboard. Never saw a computer.
Wow.
He went to the lab and he didn't know what a breadboard was. He didn't know how to do anything because it was all theoretical taught to him. So we look at that and go, morons, like just use the stuff. I remember going to the bookstore to order computer books. I don't do that anymore. I
Yes.
just Google it or I go to YouTube. So ChatGPT is an iteration of that. It's not, I don't know.
You used to have to wait every month for the magazines to come out.
Mr. Herman, you said you've been in this AI for 3 decades now.
No, 10 years.
10 years.
Before that, it was computer science.
Gotcha.
Yo, don't
How
try and
excited
age
are
her,
you
Jiho.
now
Come on.
Oh, it's
Versus how excited are you now versus 10 years ago?
Oh, it's amazing.
Yeah.
It's amazing. The growth is quite fast.
Exponential.
Yeah, definitely. Yep, go ahead.
Well, what's the invention of bias? A lot of people are just taking word for it, but I can see when you're looking at AI to, to be the best candidate for this job, like obviously human bias surrounding that.
Mm.
What do you think's being done for that?
Bias is
So it's kind of like saying, hey, we are using computers to process data now. It's just doing it faster. It's not doing it different. So whatever AI can do, it's just doing it faster.
It's got the
We're talking
same
about
biases
we're
that.
talking about recognizing white faces versus brown faces or whatever. How about the medicine you take? How many aspirins? Is the amount of aspirin he takes should it be the same as me? Why is that? Because most test subjects for drug trials are young college students that are white males. So it's not an AI
There's
problem.
only one of those
It's
things
an
that's me.
AI elevates the problem. It makes it more clear.
Right.
So is AI going to fix it? No, you and I have to fix it, right? And there are groups and bodies that have ethics in AI that try to do that, but we're humans, we're fallible.
Not her, you haven't met her yet. She's not.
But yeah, it's like, what are you gonna do?
Question. Lo?
Yeah.
Quick question. You mentioned about like the integration of quantum computing into AI. As I understand, most of these quantum computing systems work into probability, like results instead of like a binary results. Wouldn't that add like a huge layer of noise, like when training the model, the function system?
So I'm not sure I understand your question, but I'm going to try and answer it anyway, based on what I think you're asking. Quantum computing goes from 2 states to 3 states. So it's just faster computing, right? What you do with it is a whole different thing. As far as noise in models, you want noise in models. You want models to be noise resistant, right? You don't want it to be that it'll only give you a dawn or a muffin if it's a perfect dawn or a perfect muffin. You want the noise is actually a good thing for to train against with data. How much noise is up to you, right? So yeah.
So I've been learning about machine learning by my own, so I have a bunch of questions. Because when it comes to like apply for a job, I see that there is so much things to learn. Like this topic is huge. So what's actually the industry looking for when they like are hiring machine learning?
So you should write a Python script that scrapes the job boards
Mm.
and looks for the most paid for, most asked for skills.
Oh,
And that can be your model to present to the interviewer saying, look, I've done it.
nice.
Do I have the answer? No, I don't.
That's brilliant.
Okay.
Google Trends.
No, there's more than that.
I know.
Yeah.
That's searches.
You just said that with quantum computing, we're gonna go from binary to trinary, right? So Damien always jokes that he's so old that when he started computers, there was no zeros, just ones. We're all gonna, you're saying we're all gonna be able to say back when I was learning computers, it was ones and zeros. We didn't have twos like you have now.
Mhm.
Wait, we're gonna be old, I mean, I have years.
Yeah. We'll be older.
All right.
Eventually, everybody's older.
All right.
Well, thank you for coming. Hopefully you learned something.
Thank you so much.
Thank you, Barkha.
Thank you, everybody. So definitely reach out to the links. You want to put the
Yeah,
links back
so
on?
if you wanna contact me, LinkedIn is the best place.
Okay.
And I'll put it here, so it's. I ignore most other things except LinkedIn.
Nice.
So I will get back to you on other channels, but
Yep.
on LinkedIn I'll be faster, so.
As always, there is an event like this every single month. You guys know this in both FLA.net and FloridaJS. Thank you so much, Barkha. We were sick and tired of hearing the last presenter, so I'm glad that we have a presenter. And some of the other ones that you want to present. Reach out to me.
I do have a lab that is, so Microsoft is working on a library for quantum computing. So whenever quantum computers become available, you just plug in. You can still use it. It'll emulate the quantum computing bits.
Right.
And they have the traveling salesman problem being solved using, and I wanted to do a hands-on lab for it forever. So if you want to do that. And then also, I am doing a hands-on lab for the Apache Pinot, which is a OLAP database that LinkedIn uses for their, stats and all that stuff. If you're interested, join me. It's virtual, so if you connect with me on LinkedIn, you'll find it.
Perfect. Thank you very much. All right, guys. We have some kids outside. We have some snacks outside. You guys are welcome to stick around, or you're welcome. Oh, there is, yes. If you guys want to, is there a way I can put up? Well, I can get it over here.
Yeah, just.
So.
I'm not connected to it, so
Yep.
you wanna
Absolutely.
move my-
You guys are interested in a prize? You guys can stick around from JetBrains. You're gonna have to give me some time for the person to get up there. But before you go, remember that we meet once a month. Give me 1 second. If you wanna go ahead and join me. Guys. Hey, this is the only thing I asked for. Shut up. Jeez, right. Free presentation from an expert. You guys are like. All right. Sorry, I'm a dad. I have to do those things. So check out the group. Come back next month, and you're interested in a free bit of stuff from JetBrains. Stick around. Otherwise, check out everybody else outside. Bye. Yay. Thank you so much.
Thank you.
I don't want to, I'm going to plug it into the wrong place.